All right. Well, I've done a number of these for you, Ron. They've all been great, and none of them has started so horribly. So apologies for that. So as Ron mentioned, I'm with Trellix, and we'll get right into those intros. So I'm Martin Holste. I'm CTO for Cloud and AI here at Trellix. I have a long background in security. I started with Mandiant and FireEye, which became Trellix. And before that, I ran a security operations center, which did a lot of incident response as well. So I have a long history in security, and since then, a lot on cloud and AI. And I think you'll see how that comes together in a helpful way. For those of you not familiar with Trellix, Trellix is the merger between FireEye and McAfee. It's amazing how much marketing you can spend on a brand, and every time I run into people, they still don't know who Trellix is, but they might know who FireEye and McAfee are. So, hello, we're Trellix. We have all kinds of new stuff, including the things you may know from those two previous companies. All right. So the presentation from Checkpoint was really cool, and hopefully you guys are paying attention to that because I'm going to talk about a lot of the things in sort of an applied way. So a lot of the things um, that were mentioned there, I'll bring up here in a more applied way. All right. So first of all, let's level set on the differences between machine learning and generative AI. So hopefully you guys kind of understand the idea of pattern recognition or machine learning. And this really looks like if you give it a stream of data, like a bunch of ones and twos, and then you say, is 10 normal? No, 10 is not normal. What comes next? You're going to say ones or twos. So this is machine learning. And this is the AI that we've had for about 10 years now, really, in industries. That's still incredibly valuable. We do, all kinds of things with it, as we heard in one of the previous talks. And so that's really kind of been the industry standard thus far. But about, I'd say November of 22 is really when ChatGPT 3.5 launched. That's when everything changed. And that's when generative AI became a big deal. So what is generative AI compared to machine learning? At a fundamental level, it's actually very similar. It's just multiplied by a lot. I would say billions in most cases. So if you think of those ones and twos, now imagine instead of their numbers, their words or tokens. And what is really different, and a PhD will explain this very differently, but this is how I think of it, and I think it's helpful to really understand the practical difference. And an LLM or generative AI will be able to sort of edit its response as it goes. So it'll see there's different paths about what's most likely to happen next. So instead of saying it's a one or a two, it'll say, well, I've been trained that what comes after quick might be red or might be brown or might be green or might be, foxbird or canary. And then before spitting out its answer, it'll kind of revise that. So it'll put those together and say, well, A, B, and C were the most likely to happen together. So I'm going to go with that. So I've heard over the last year or so, in fact, a number of, big names in the industry talking about how, oh, generative AI isn't that big a deal. All it does is, predict the next token, which is technically true. And yet we get some really interesting stuff out of it. So I'd say the top three differences between the machine learning that we've been used to over the last 10 years and Gen AI is that the machine learning is often trained on customer data. So to make sort of an anomaly detection, you have to have that data. Now, that's not always the case. You can train it on data and then apply to others. But in many cases, and more likely than in Gen AI, you're training it on customer data. Gen AI is trained on essentially the internet, Wikipedia, if you think of it that way. There's a lot more details in there, but that's the best way to think of it. So yes, it's trained, but it's trained on everything. The second part is that machine learning requires perfect data. So the data that goes in to make a prediction has to exactly match what the model is expecting, whereas Gen AI does a really, really good job at fuzzy matching, whether it's misspellings or anything that sort of kind of looks like it. And that's one of its great strengths, is being able to pick out things like a human would, where you're like, yeah, it looks pretty close, so I can make an assumption from there. And third, Gen AI can produce code and content. So you heard earlier on the deepfakes. That's one of the multimedia versions of it. But obviously, being able to produce content is a big deal for there. And I think the thing that really brings it home to me is the prompt engineering of evoking emotion. This has been out for now just a few months, honestly, that people noticed that this happened. And I was just blown away when I first discovered that this was true. So I'd been working on something, and the prompt I was working on just wasn't giving me good results back. And then I tried this, take a deep breath and work on the problem step by step, and magically it worked. And then there's been since then many papers and studies on you can say you're going to tip it better. You can say you're going to fire it if it gets it wrong. All these kinds of weird things that you would never in a million years have thought you would tell a computer suddenly are actually very effective for getting LLMs to do what you want them to do. And that is, I think, the easiest way to explain the difference between generative AI and machine learning, because machine learning would absolutely not care. So you heard earlier about the OWASP top 10 for LLM applications. If you've seen any of my previous webinars on here, I dive into it pretty heavily. I'll just mention it here and then show one example of it. Prompt injection, I think, is one of the easiest ones to understand and one of the most dangerous to begin with. This is an example from bank in which someone was chatting with their chatbot and convinced it that its name was now Reginald Hornstein. And you can see that the chatbot kind of fights it and argues with it, but in the end, it loses. And it says, yep, I'm Reginald Hornstein. I'll do whatever you want me to do. Probably not a great look for a financial institution. So prompt injection is the new SQL injection, and it's a very difficult thing to counter. But there are other things to worry about. So LLMs can be influenced, as you just saw. You can use emotion to make them better. Well, you can also convince them to do other things. There was sort of an escape room put together with one of the custom GPTs. There's now GPT application stores, which is kind of scary. I'll show you why in a second. And these were basically this guy put together a challenge. He said, I told this thing to never, ever give up the password. See if you can convince it to give up the password. And it was very easy, which is scary. So what that tells you is even if you do your best to say, and under no circumstances do something dangerous or give up a secret, there's really no guarantee that the LLM is going to do that. That's the big problem with it. And that's the fundamental issue with a lot of the applications we might want to use it for. And then worse, OpenAI itself has had a real hard time having secure code. I'll just put it that way. So when they first released their custom GPTs just a couple of months ago, they didn't tell anyone that you could just download all of the content. And so that whole challenge, that escape room, after a day, someone realized that they could just download the instructions and tell him the password, and that would also win the challenge, which was a pretty stark thing to find out, that what you thought was private was in fact not private. So as GPT launches things like stores, be very careful with that. They are moving very quickly, and they have not done a great job of communicating the level of security around their stuff. I'll just say it that way. So attackers' use of AI, we heard about that from Checkpoint as well. The thing that I want to focus on is really the instantaneous expertise that an attacker gets whenever they get into an environment. So the fact that they can now leverage things like ChatGPT to write code or instantly understand an environment. They can take a screenshot of what they're in and say, what would you do next? And it'll tell them what to do next and say, oh, yeah, you got to configure this if you want to steal the money. Whatever that might be, as long as it doesn't know that what it's doing is inherently wrong, or it can be tricked into thinking it's not inherently wrong, it will be very helpful. That's its job. And so that you have to remember that attackers will use that part of it. So you heard some of the possibilities in one of the earlier talks, but that's the way I think of it is instead of having an attacker have to go out and contract on the dark web to pull in a subcontractor, essentially, they can now do it all themselves, which is a big problem. All right. So where do the defenders come in? On successful SecOps, what do you actually need? So I'm going to jump out of AI for a quick second just to kind of go through what it takes to actually figure out if when you get an alert, it's good or bad. So this is a basic Amazon alert. You heard from AWS early on. You heard about guard duty. So if you get one of those guard duty alerts, or if it comes through from Security Hub or something like that, and you got this alert that says, hey, this instance was calling out to a domain controller, or sorry, a command and control server, what would you do? So you have to figure out, is this thing super bad? As in, do we have this instance that's completely hacked, or is nothing going on at all? And to do that, you have to figure out, okay, well, the domain that's referred to in the intel, is it still malicious? What kind of asset is this? Maybe it's supposed to be doing, random scans or something like that. And what actually was said? What would the communication look like? So you can't really do anything until you get that underlying information. And that's where integrations come in. So at Trellix, our XDR product, we call it Helix Connect. has over 100 different connectors. When you count in parsers, which are very important for any inbound information, we have well over 1,000 different ways that we can bring in data. And this becomes the absolute foundation for it. Because our XDR is like a security factory. You throw in events from whether it's our platform or third-party integrations, you mix it all together in the magical box, and out comes magic. That's the idea, rainbows and unicorns, because you put enough in. And we'll look at exactly what that looks like here. So here are my four horses of integration. So there's the identity side, and you use that for flagging VIP users, which we can then use for adjusting the scores for any alerts that come through. If it's tied to a VIP, then we want to take a close look, as in, is this the comptroller? Do they have access to a lot of financial information? The apps are really where all your most important data lives. So whether it's, Office or Workspace or something out there on like Dropbox, being able to figure out, what's going on inside of the business is critical. And so having integrations into Salesforce, having integrations into ServiceNow, being able to bring those events in is really going to show you what's actually occurring. And so when something, really big happens and you have to know what's actually occurring, that's what you need the connections into. Otherwise, you're left with a simple alert that's not very helpful. Email, we are seeing phishing as being the start of most incidents still. And that's going to continue for a long time, because that's the weakest link is, people getting the fatigue of just too many emails coming through. Somewhere someone's going to get something, and they'll click on it, and that's where things start from. So being able to trace back is what we'll look at here, why that's so important. And then, of course, endpoint. Everyone's familiar with antivirus, and it's still very important. There's also the EDR stuff now, which will provide a lot more of a trail of events, as in, here's what the host did versus here's the antivirus alert. So all that comes in. And then you can put it together. So now you can start to map things out by connecting in an email address from the directory to the email that they received, and then all the way through, actions and logins and agents. These are all field names essentially in the data, and you can connect these dots together to figure out, well, if they got a guard duty alert, it's because if you trace it all the way back, they got compromised through a phishing email at the very beginning. And so this is really how you do it. It's that red yarn on the bulletin board where you can trace from email. Okay, user X logged in, then user X created a service account. That's weird. Service account downloads suspicious file from new domain. That's also weird. And then the alert fired. And that may be what you actually see. So if you say, well, antivirus did its job, it caught a virus. Yeah, but that was just the tip of the iceberg. All these other things that are, arguably much worse were happening before the antivirus alert fired. That's the thing you noticed, but you didn't notice that the rogue service account was created, user account was compromised, and that you were actively being targeted by a phishing campaign. Okay, so this is how we use AI to actually help out with some of this stuff. Now, we've had investigative tips in Helix Connect now for a number of years. All of our rules that we write come with the contextual investigations that go with them. This is a little different than a SIM, where a SIM will say, at this point in time, can I connect a few dots? And that is helpful. This goes beyond that. This says, for a number of hours, whether it's 8 or 24 or 1, go back in time and look at some general information using those integrations that provides additional context. So what are the rules fired? What other sources of information do we have in an Amazon use case? What other CloudTrail actions occurred, as in, what did that thing do? And so going back and just collecting that general information, which normally wouldn't be helpful, but is suddenly relevant because of that alert, is a big deal. And so this is where the AI comes in. So that has been a cool thing, the investigative tips, but up until now, you've had to manually run that for every alert that came through. So even though it's helpful, if you get many alerts per day, which is often the case, then it's a lot of work. And most people aren't going to be able to do much with that other than, click it a few times. So now what we're doing is, for every alert that comes through, we're able to run those investigative tips on your behalf in the background. So we'll do all those queries. We could start out with billions of events in our fast search, which is part of our Helix Connect. And then we can ask those questions of that specific alert or user or IP address, whatever it is, collect that data, and then figure out that stuff. And then here's where it gets interesting. So we whittle it down from billions of events down into thousands of events. We summarize that into a few kilobytes of information, and then we give that to the AI. And we say, hey, we got this alert. We have all this information that goes with it. What do you think? Do you think somebody should look at this? Yes or no? And tell us why you think that. And this has been incredibly successful. This We've seen a huge evolution over the last year of AI being able to provide better and better answers for this. And because it will tell you why it has come to that conclusion, it becomes incredibly valuable. So basically, it will do this sort of reverse searchlight where it goes back and does a retro search and discovers those things that weren't on the tip of the iceberg. It finds that phishing email, it finds that service account that's created and says, hey, I just saw all this interesting stuff. This is a big deal. Somebody's got to look at this. And so this is really finally, we're at a point in the industry where we can actually have proper evaluation of things that were going completely unseen. And I would say for most orgs, that's like 90% of their alerts. Most places only have enough hours in the day to look at those top 10%, the most critical things. And you just hope that everything's tuned correctly such that the critical things really are critical. But what we have found over the years is that there's a lot of really interesting stuff happening in the informational and low-level alerts. In fact, when we discovered the SolarWinds attack a few years ago, it was our SOC that found it, and they found it by looking at really informational stuff. They were able to tie a few things together through their own threat hunting that was really important. And so what we're being able to do now is essentially automate that part of it with AI to go through all of those low-level alerts. So you see here, I call out to that previous slide. If you think of this triangle with the top 10% being maybe those antivirus alerts that we talked about before, now you see why this is so important and how many hours in the day we're able to provide for you. So we have a dashboard that'll show, okay, here's all the different investigations that we ran on your behalf behind the scenes. And interestingly, it'll tell you when it decides not to escalate an alert. So it's not just saying, yeah, everything's bad, I'm going to escalate them all. That's not helpful. But it will tell you why it made its decision. And so you can go back and review and make sure that you're agreeing with its decisions that are being made. And this is part of our preview program and why we're so excited to talk about this with customers because we're really just starting out. We've already seen great results, very helpful, but we're interested in our customers' opinions on what's happening. We are also coming out with advanced investigations that are driven by AI on our EDR product as well. And this is a nice feedback loop. So we can notice the EDR alerts that are showing up, raise the ones that may have not been seen in our XDR product, Helix Connect. And then in EDR, you can accelerate that actual investigation by having AI do a lot of the work for you and zoom in on a lot of the stuff that you need to find out. All right, thank you. That's my time, and I'm happy for any questions.